Hey guys, I wanted to go over the problem 8C that was assigned yesterday, mostly because 9 kids were absent today and I just wanted to make sure everyone saw it because I did it in class today. Also, if you were here and you just wanted to see it again or again and again, here's your chance. Okay, so 8A, by the way, is easy because if you kind of draw all the field vectors, just remember, just draw them like a free body diagram. You see that they cancel out pretty quickly, right? They all point in the 4 different directions and they're all going to sum to 0. Okay, let's do that here though. I want to find the field in the center here when I have these 4 charges, which I've labeled A, B, C, D, just so we can call them something. And they're all kind of separated and they're in the square length S. Great. I want to find the field smack dab in the middle. So let's start by doing what would be a free body diagram if these were forces. But remember, this is not a force because there's nothing at this point. It's just a point. So EA points this way. EB points this way. EC, I'm going to use a different color just so they don't overlap because EC is going to also point this way. Right? Just remember, if I put a positive test charge, which way would he push? And ED points this way. Okay. Before I move on, I should let me first kind of draw some axes. Yay, axes. Okay. And I drew them like this so that, well, I'll say why in a second. First, let's remember that the fields are the same. EA, EB, EC, and ED are all the same. How do I know that? Well, the field due to a point charge is KQ over R squared. Not on your equation sheet, very important. Right? It's another equation that's not on your equation sheet, is related to things on your equation sheet. You got to know, it's really helpful. Okay, and Q is the same, right? They all have the same charge. And also the distance, this R, which represents this distance here, is the same for each. Okay, so E's are the same. If I made the axes like I did, y and x, then E sub y, the net field and y-axis is 0, because there's as much upfields as downfields. And also, the fields, therefore, are all in the x. So sigma, the total field, equals the field of the x-axis. And that's just for EA, right? They're all, sorry, EAX. It's for EAX because all the x components add, and they're all the same. They all point right. EAX points right, EBX points right, ECX points right, EDX points right. Let's draw EAX in this rectangle here. I'll draw it like this. I got EAX, EAY. Okay. And all I got to do to know this, to get EAX is to know this angle. Well, this is going to be a 45 degrees. 45-degree angle. Okay, why is it 45 degrees? Well, it's because it's this line over here is bisecting a square with this 90-degree angle. So I can write the net field as for EA cos 45. It's cos because it's adjacent over hypotenuse. And now all I got to do is plug in this KQ over R squared thing. So the net field equals 4 KQ over R squared cos 45. Now at this point, you might say, wait a second, I think you're done, but I'm not. Because R is not a given. Everything else is a given. Everything else I'm totally cool with. 4, K, Q, 45, all great. Okay? But R, I got to write that in terms of something else. And luckily, I have something else. I have S. So watch. If this whole thing from here to here is S, then this thing from here to here is S over 2. Okay, and I can kind of make this triangle over here. And I can either use Pythagorean theorem, because this is also S over 2, or right angle, our good old friend right angle trigonometry. Let's do trig. Cos 45 is equal to S over 2 adjacent over hypotenuse. Okay? I can rewrite that in a couple of steps as that. And since cos 45 is rad 2 over 2, that's going to be S over rad 2. You need to look at the math again. Stop, spend a minute, do it. R squared then is equal to S squared over 2. Throw that in there. Okay. That 2 comes to the top and it becomes net field equals 8 KQ over S squared cos 45. If I really want to be fun with that, since this is still radical 2 over 2, it's the net field equals 4 KQ over S squared radical 2. But I don't really, there's no difference. No one really cares about the math. And that's it, guys. See ya.